object at rest tends to stay at rest, and an object in motion tends to stay in motion, with the same speed and in the same direction unless acted upon by an unbalanced force. In fact, it is the natural tendency of objects to resist changes in their state of motion. This tendency is described as inertia. A more massive object has a greater tendency to resist changes in its state of motion. So basically, Newton's first law is any object in motion stays in motion unless acted upon by a different unbalanced. As you can see, there was no force acted upon the car, so it continued to stay in motion because there was no force acted upon it to stop it instead. The car was at a constant motion until it ran into the wall, which was the external force, and it stopped it from being.
As stated in the first law, the presence of an unbalanced force will accelerate an object, changing either its speed, its direction, or both its speed and direction. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The acceleration is always in the same direction as the net force.
I'm dragging it.
As you saw, the cars, the one blue one was stronger than the other one, and the force of that blue one was bigger, causing to move the other one. The net force of the cars pushing was stronger with the blue one, so it caused it to accelerate in the blue car's direction.
A force is a push or pull upon an object. This implies there must be two objects, one being pushed and one doing the pushing. Thus, forces result from interactions between objects. According to Newton's third law, whenever objects interact with each other, they exert forces upon each other. These two forces the objects exert on each other are called action and reaction forces. Friction is one type of reaction force. Since the wall did not push back and I did not get pushed back by the wall, I created an equal and opposite reaction force. Since it was equal because I didn't go through the wall or the wall didn't push me back. As you can see, on the bottom of this is sandpaper. This means that the friction is greater. So, as I dragged it across the floor, it was harder to pull than this one that was lined with cloth. The cloth has less friction against the floor. Therefore, it was easier to pull. So the more friction an object has, it's harder to pull, the less it is easier to pull.